How do electrical transformers work by Faraday's law? Imagine a machine that can change the voltage of electricity without moving parts or fuel. That's what a transformer does, and it all comes down to a simple scientific principle. When you send an alternating current through a wire coil, it creates a magnetic field that constantly changes direction. This changing magnetic field is key. It flows through a core made of iron or steel, which guides the magnetic flux efficiently. Think of the core as a path that directs the magnetic field where it needs to go. Faraday's law tells us that if the magnetic flux through a coil changes, it induces a voltage in that coil. So, when the magnetic field in the core shifts because of the alternating current, a voltage is generated in a second coil wrapped around the same core. This second coil is called the secondary winding. The amount of voltage induced depends on how quickly the magnetic flux changes and how many turns of wire are in the coil. More turns mean a higher voltage, and fewer turns mean a lower voltage. This is the core idea behind how transformers change voltage levels. If the secondary coil has more turns than the primary coil, the voltage increases, which is called stepping up the voltage. If it has fewer turns, the voltage decreases, known as stepping down the voltage. This process is essential in power systems because high voltages are used to transmit electricity over long distances efficiently. In power generation plants, transformers step up the voltage to reduce energy loss during transmission. When the electricity reaches homes or businesses, other transformers step down the voltage to safe, usable levels. This way, transformers help deliver electricity safely and efficiently from power plants to your home. In renewable energy systems, like solar farms or wind turbines, transformers are used to match the voltage levels needed for grid connection. They ensure the power generated is compatible with the transmission network. So, in essence, transformers work by harnessing Faraday's law, turning a changing magnetic flux into a controlled voltage. They are vital in managing how electricity moves across the power grid, making sure it gets from the source to your outlet safely and efficiently.